Hi everyone. In this video, we're going to look at solving polynomial inequalities. In this first example, we want to solve the following inequality. X minus 2 times x plus 3 times 2x minus 1 is greater than or equal to 0. To solve this inequality, we want to find for what x values can I plug into my polynomial on the left here so that the polynomial is greater than or equal to 0. There's a couple of different ways we can do this. One way is by graphing this polynomial out. So let's try to graph this polynomial. Now remember, to graph this polynomial, what I need to know is I need to identify what are the zeros, or in other words, what are the x-intercepts of my polynomial. Right? Because if I know my x-intercepts, that's going to help me graph the polynomial. Something else that will be helpful when I graph this polynomial is to know what's the end behavior of the polynomial going to be. Okay, so let's start by drawing out the graph. The zeros, or the x-intercepts of my polynomial, are going to be the values of x that make each of the factors inside my polynomial equal to 0. So for the first one, x minus 2, well, the value of x that's going to make this equal to 0 is x is equal to 2. So that means 2 is going to be a 0 on my polynomial. Next, we have x plus 3. The value of x that makes this equal to 0 is negative 3. So that means negative 3 is going to be another 0 on my polynomial. And lastly, we have 2x minus 1. The value of x that makes this equal to 0 is x is equal to 1/2. So that means we're going to have another 0 at 1/2. Okay, to help us sketch this function and see where it's positive or negative, it will be helpful for us to identify the end behavior of this function. So in other words, the end behavior, where is this graph going to approach as x gets really, really large, goes really, really far to the right, or really, really far to the left? Okay, to find the end behavior, we need to know two things. We need to know, okay, what's the degree of this polynomial? And what's the sign of the leading coefficient? Now the degree, if you look at my factors, I'm multiplying an x here by another x by another x. Right? I know if I multiply x by itself 3 times, that gives me x cubed. So what does that mean? The degree of this polynomial is 3, because here we can see I'm multiplying x by itself 3 times. My leading coefficient. Well, if you look at the number that would be in front, well, the numbers in front of my x here are all positive. Right? So since the numbers in front of x are all positive, if I multiply these all together, then my leading coefficient, the number in front of the x cubed, will also be positive as well, because the numbers in front of my x's and my factors are all positive. So if I have a degree of 3 and a leading coefficient that's positive, that means what? That means my graph is going to extend from quadrant 3, so this quadrant right here, to quadrant 1, this quadrant right here. So let's draw that out. So we know it's going to extend from quadrant 3 to quadrant 1. And now I can just draw my curve so it goes through these x-intercepts here. And now there we go. There's my graph of this function. And looking at this graph, I can see where my function is positive, where it's positive and where it's negative. Okay, so based on this graph, I can tell that my polynomial is going to be greater than 0. It's going to be positive when x is greater than 2. And it's going to be equal to 0 when x is equal to 2. So, since I want to find out where this polynomial is greater than or equal to 0, I'm going to want to say, okay, this is greater than or equal to 0 when x is greater than or equal to 2. Now similarly, I can see when x is between negative 3 and 1/2, this polynomial is greater than 0. So the way I would write that is like this. Also, this polynomial is equal to 0 when x is equal to negative 3 or when x is equal to 1/2. So I'm going to want to put an equal sign right here, like this. So we can see from the graph that these are our two solutions. Okay, so that was one way you could solve this inequality, by just graph it out. Another way you could solve it is by using a sign line, what's called a sign line. And the way the sign line works is you can kind of imagine. Okay, I've drawn a horizontal line here. And let's imagine, on the bottom of my line I have x. And at the top of my line I have this polynomial, which I'm going to label p of x. To find where my polynomial is going to be greater than or equal to 0, I can split this sign line up into different regions. And the regions I'm going to want to look at, okay, I'm going to want to look at where my x-intercepts, because I know from my graph that my polynomial can change sign at around the x-intercepts. So I'm going to want to put down my x-intercepts on my sign line. My polynomial is equal to 0 at our x-intercepts, right? Because those are our zeros. And now the way the sign line works is you want to, in each of the four regions I have here, I'm going to want to try plugging in a value of x into our polynomial. So let's look at the region here where x is less than negative 3. I'm going to want to try to plug in a value of x that's less than negative 3 into our polynomial. So let's say x is equal to negative 5. And something I want to mention too, it doesn't matter what value of x you plug into the plug-in that's less than negative 3 here. Right? As long as the x value is less than negative 3, then we can try it out. And now, we just want to see, so if we plug it into our polynomial, we want to see, is our polynomial going to be positive or negative? Well, let's try. So if I try plugging in negative 5 into my polynomial, then if I look at my first factor here, x minus 2, well, if I plug in negative 5 into x minus 2, I'll get negative 5 minus 2, which is a negative number. If I plug in negative 5 into my second factor, I'll get negative 5 plus 3, which is also a negative number. And if I plug in negative 5 into my third factor here, I'll also get a negative number. A negative times a negative times a negative is a negative. And I can keep going. I could do the same thing for the other three regions as well. So I can plug in a value of x into this next region, where x is between -3 and 1/2. So for example, I could try plugging in x is equal to 0. And if I plug in x is equal to 0 in my first factor, this is going to become a negative. If I plug in 0 into my second factor, that's going to become a positive. And if I plug in 0 into my third factor here, that's going to be a negative. A negative times a positive times a negative is a positive. And I can keep going. I can keep going. Okay, I can plug in a value between 1/2 and 2. I'm going to go over this quickly. And same thing, right? I just need to identify if I plug in x is equal to 1, okay, what's going to happen to my factors? Are they going to be positive or negative? And then, okay, I can see I have a negative times a positive times a negative, which is a negative. And I'm going to do the same thing when x is greater than 2. So I'm going to plug in a value greater than 2, so say 3. And then we're going to do the same thing, right? Identify is it positive or negative there. Okay, we're multiplying three positive numbers together. So our answer is going to be positive. And we can see, like, same thing from the sign line as well. We can see, okay, what regions is my graph going to be positive? In which regions is my polynomial going to be positive? And in which regions is it going to be negative? And we can use the sign line to figure out what the solution to this inequality is. And the reason why this sign line works, and the reason we split it up this way by looking at the zeros, is again, we know that around the zeros, my polynomial can change sign. So that's why we always want to, like when we're using a sign line, we always want to split the sign line by looking at the zeros, the x-intercepts of the graph. So those are two ways you can solve polynomial inequalities. And you can always choose which way you find easier or better. So in the previous example, we looked at an example of a polynomial that was already in factored form. What if my polynomial is not in factored form? Well, if it's not in factored form, then we would need to factor it first. And we can quickly look at this example and see how we can factor this polynomial out. Now remember, to factor a polynomial, I'm gonna need to find a 0 first. Now, to help us find the zeros, I can identify factors of my constant term here. My factors of my constant term are these. I'm missing a 4 there. Okay, so these are my factors of my constant term. The factors of my leading coefficient here, which is 1, is just plus or minus 1. So that means to help us find the zeros, I want to try plugging x values in the form b over a into my polynomial to help us find the zeros. Okay, and if I divide b divided by a, well, if I divide these values by positive or minus or a negative 1, that's not going to change these values, right? Like if I divide these by positive or negative 1, I'm still going to get these values back when I do that. So that means I want to try plugging some of these values into my polynomial to help me find some of the zeros of my polynomial. Now, let's say I plugged in 1, x is equal to 1 into my polynomial. And you can do that. So if you plug in 1, you can see, and you can see when you do that, that you'll get 0. So when I plug in 1, I get that this is equal to 0. So what does that mean? That tells us that x minus 1 is a factor. To help me find the other factors, I'm just going to divide my polynomial here by x minus 1. Let's do it. So again, I'm gonna quickly go over this. Okay. Here, I know. Okay, x times x squared gives me x cubed. If I multiply this by x squared, I get this. Okay, now if I subtract these two together, if I subtract these two, I'll get, okay, x cubed minus x cubed, that will cancel out. Negative 2x squared minus negative x squared is going to give me negative x squared. And then I'm going to bring the negative 11x plus 12 down. And we can keep going with this as well. All right. So I divided my polynomial by x minus 1, and I got x squared minus x minus 12. Okay, so what does that mean? So okay, I divided my polynomial, and I got that this is equal to x squared minus x minus 12. And now, since I want to fully factor this expression, I'm going to factor this again. Okay, so to factor x squared minus x minus 12, that's going to be equal to x minus 4 times x plus 3. Okay, and since I just want to get this polynomial, x cubed minus 2x squared minus 11x plus 12 by itself, I'm going to multiply both sides of my equation here by x minus 1. And then I'll get that my polynomial is equal to x minus 1 times x minus 4 times x plus 3. And there we go. So now we have we factored our expression. And now we can either graph this polynomial out or use a sign line to see, in this case, where's my polynomial less than or equal to 0? So I think for me, for me, I usually find it easier to graph the polynomial out. So let's graph this quickly. Okay, so the zeros of my polynomial here are 1, 4, and negative 3. Because these are the values of x that make my factors equal to 0. The degree of my polynomial here is 3, and my leading coefficient is positive. So that means, just like the graph we looked at before, my end behavior, this graph is going to extend from quadrant quadrant 3 here to quadrant 1. So my graph is going to look something like this. And I can see, okay, from my graph here, my polynomial is going to be less than or equal to 0 when x is less than or equal to -3. Also, my polynomial is less than or equal to 0 when x is when x is greater than or equal to 1, or when x is when x is between 1 and 4. So we can see that our polynomial is going to be less than or equal to 0 when x is greater than or equal to 1, or x is less than or equal to 4, like that.